Action.
Hi, the three members of our group, Dongwenxi, Yang Yuxiao, and Wang Xin, will introduce stratospheric observatory for infrared astronomy in different parts. My name is Wang Xin, and today I will first introduce the introduction, location, and the research project of SOFIA. Stratospheric Observatory for Infrared Astronomy is referred to as SOFIA. SOFIA made its debut on May 26, 2010 with the collaboration of German Aerospace Center and the University Space Research Association. SOFIA is an infrared space telescope designed to study the solar system and beyond, and is the most sensitive and the largest mobile observatory known as the Airborne Observatory. As we can see from the image, that the SOFIA telescope is mounted on an airplane. In fact, the SOFIA is mounted inside a modified Boeing 747 with the inside door open. The observatory's mobility allows research to observe from almost anywhere in the world and enables studies of transient events that often take place over oceans where there are no telescopes. Each time the SOFIA carries out a mission, it is about 12 kilometers above the ground, and the 7-ton telescope will be able to observe the night sky above most of the atmosphere, where more than 99% of the interference from the atmosphere and the water vapor will disappear, far better than the ground-based telescopes. And the next part is a research project. The SOFIA telescope is designed to observe the infrared universe. As we can see, this picture is one of the infrared photos taken by SOFIA. Objects in space emit their energy in infrared waves, which can pass through celestial clouds of gas and dust. In both cases, the only way to study objects is to study the infrared light they emit. Only SOFIA telescope, who works in the stratosphere, can give scientists data in the middle and far infrared bands. Scientists use the data to study when the star was born and died. The recognitions of complex molecules in space, the magnetic field of celestial bodies, and other important studies.
Okay, it's my part now. So my name is Dongwenxi, and I'm gonna introduce the EM spectrum of SOFIA. So here is a graph shows the wavelength SOFIA can observe. It's between 300 nanometers and 10 to the power of 6 nanometers, which include visible light and infrared. And the wavebands of infrared can be broken into near infrared, mid infrared, and far infrared. The main factor that will determine the wavelength of these three infrared regions is the detector used for gathering infrared light. Near infrared can be only observed by ground-based detector. Mid and far infrared can be detected by the detectors which are above atmosphere. Okay, so next part is why NASA spent a lot of money on SOFIA. In scientific aspect, SOFIA has a great potential. Of course, it has to take off and land every day. So scientists can improve or update the instrument easily. The graph, here is a graph, and the graph shows the difference between visible light and infrared light. The left image is infrared light, and the right image is the infrared light. The dust blocks the majority of the visible light, but it will shine brightly in the infrared. In economic aspect, produce the relevant instruments on SOFIA is related to a big industrial chain. It can be drive a lot of manufacturers, which is relevant to developed. In political aspects, SOFIA is a multinational cooperation program which cooperates with German Aerospace Center. It's positive for relationship between multi-countries.
So my name is Yang Yuxiao, and such a big telescope, how does it collect data? According to this graph, when the light comes down, it's being captured by the primary mirror, which is about 0.4 meters across. The first reflection is formed by light passing through the primary mirror. And about 1 meters above the primary mirror, there is a second mirror. The light is reflected in the second mirror to form a second reflection. After that, the second mirror is reflected in the last mirror, which is the tertiary mirror. Finally, the tertiary mirror reflects the last time, focusing the light to the focal point, and then being collected and analyzed. And then I'm going to talk about the detectors in the SOFIA. There are a lot of detectors, and now I'm going to mainly talk about these two. The first is the axis, which is the left one, and the wavelength region that axis can detect is about 4.5 to 28.3 micrometer. Due to the obstruction of Earth atmosphere, many molecules will be blocked outside the Earth, but axis high spectral resolution perfectly solves this problem. This enables us to further study the origin of these molecules. And the right one is the FPI Plus. It's the standard tracking camera for the SOFIA. It allows SOFIA to capture the trajectory of moving objects. It can detect waves in the range of 360 to 1100 nanometer, which includes all the visible light. Nevertheless, FPI Plus can also adjust itself according to the different surroundings and needs.
Okay. In conclusion, SOFIA is a mobile observatory which always flies at an altitude of 12 kilometers. And the arrangement of wavelengths is between 300 nanometers and 10 to the power of 6 nanometers. And the infrared telescope SOFIA obtained is very powerful, so it can be able to observe the objects when the light passes through celestial clouds of gas and dust. And also, SOFIA has a positive scientific, economic, and political impacts. That's all about our presentation. Thank you for watching. Bye.